Okay, hello. I'm going to go over exercise 5.2 signal conversion. This is all about the DAX. Okay, so have a look at this question. It's basically a 3-bit DAC, and it's basically saying if those binary numbers are entered in, what comes out. Okay, so for this one, we can have to, if it doesn't tell you in the question, you're assuming that logic 1 is 5 volts. So obviously, let's just write that down there. So I'll get my pen and make sure the colour's okay for everybody. Let's go for the orange today, why not? So logic 1 equals 5 volts. Okay, so what we need to do is we know that the output voltage is the input voltage multiplied by the gain. So we can work out the gain quite easily by doing the gain for the least significant bits. Let's do that. So the gain equals minus RF over R1 minus 24 divided by 300. Always work out the least significant bit. Yeah, the gain for the least significant bit. You'll see why. So there's my gain. Ooh, get that out. 24 divide 300 gives me 0.08 minus, strictly speaking, okay, 0.08, okay. And then we know that obviously gain, or the input voltage times gain equals V out. So I know basically if I've got 5 volts going in there, what is the output voltage? So let's just work that one out. I'm not going to call it V out. I'll call it V1. Okay, V1 equals. I'll label it there if you want. V1 equals V in times gain. So minus 0.08 is your gain times your 5 times your 5, 0.4. 0.4 minus 0.4 volts. Okay, so the first question is basically if the number 3 is being pressed, what will be the output volts? It's going to be 3 lots of 0.4. I can do that in my head. Notice it's asking V out there as well, so you don't need the minus sign because this bit inverts it back, doesn't it? It's an inverting op amp. So listen, look how easy this is now, right? 3-bit 3 times 0.4 equals 1.2 volts. Done. That's 5. 5 times 0.4. Yeah, you can see that equals 2 volts. 7 times 0.4, 0.4, 2.8, isn't it? 2.8 volts. So the thing is, work out your gain. Obviously, you can work out always for the least significant bit. So work out least significant bit first. So let's just write that. Work out LSB first. Done. Okay, here's a circuit diagram. Another one. The most significant bit is C. We know that because you can tell from the resistors. Least significant bit is that. Okay. So what is the gain, first of all, of amplifier Y? Well, obviously 100 divided by 100. It's make sure you put minus there. Minus 1 is your answer. What are the if the voltages are applied, look, there's the least significant bit only being applied there. Calculate V1 and then V2. V1 is the voltage there, so you're going to get a negative answer. V2 will be exactly the same, just take the negative bit off. So what have I got? V8 has got 5 volts going in, and I need to know the gain, don't I? Sorry. So V in times gain equals V out. There's my gain using those values. So V in times gain equals V out. I'm going to do it in one foul swoop. So V in is 5 volts multiplied by my gain, which was, I've forgotten now, is it 30 over 120, isn't it? Yeah. Minus 30 over 120. So 0.25 multiplied by your 5 minus 1.25. Okay, V2, 1.25 volts. Make sure you put units on, everybody. Okay, that is all it's asking for. Okay. What will be the maximum value of V2? Well, it's going to be 7 times 1.25, isn't it? Does that make sense? Hope that makes sense because obviously it's a 3-bit one. So 7 times 1.25 is 8.75 volts. Okay. Okay, so now we're just going to draw this. It's asking the output V2, so we know it's going to go upwards. And the easiest values to use would be 1.25, 2.5, 3.75, 5, and 6.25. Okay, we're not quite going to get all the way up to there. So we're going to go staircase, up the stairs. There you go. If you've got your glass of cocoa. Oh gosh, is that going up to there? Let me just dot across just so I can see. Going up to there. And then up to there. Okay. Just so you can see where they're going. There you go. I think, is that it for that one? Yeah, I will stop it there and I'll do them as 4 different sections. So hopefully that is a logical, nice, easy thing. The key thing is obviously making sure you just need to work out the least significant bit. The mark scheme says it slightly differently to the way I do it. If you look at the actual paper mark scheme, so you can use the mark scheme one, but I hope you agree that my way looks a bit easier because you're just using the 2 equations. Gain is V out over V in, and gain is minus RF over R1. Okay, that will do. Bye bye.